the computer for now. Okay, chapter 10.
Okay, so I think, and I remember you saying to us all when we first started the probability stuff that it tends to be that, from your experience, that students just generally overthink things. And then that's where we get our trouble. So that could be completely what I'm doing. But I was feeling comfortable with it. And then I kept doing a couple more quizzes and stuff after our chat. And I seem to be getting confused with the equation for the probability of B given A, that whole equation. And the particular issue I seem to be having is there's the multiplication rules, and given, so like it says general multiplication rule, the probability that any two events A and B both occur, the probability of A and B is the probability of A times the probability of B given A.
Yes.
I kept getting so confused. Why is the probability of B given A in the equation if that is oftentimes what we're trying to find?
You are...
The question would ask us, like, what is the probability of this given this? And then I would refer back to that equation, but then that equation had the whole given, like that was the question, and I just kept getting confused, and that, I don't know.
No, it makes sense, yeah. Let's see, let me get, well, that equation, I'm going to pull up a slide, as I think I have one equation. Let's see here. Where's? Oh, that's right there, not there. I need to put them there, though. Maybe they're here. Choose 200. Well, I could have pulled them up from the class. That would probably be the best thing to do, is pull them up directly from the class. Hold on for one more minute. Let me
okay.
Okay. In that equation, there's three major probability terms.
This is something that's, this particular part is for an independent, right? Or that they're dependent. The event's dependent, right?
Since they are dependent, right?
Yeah, okay.
Let me get rid of this. Do this. CC. I got it, of course, good deal. I got that. I'll come up to chapter 10. I'm going to pull up these slides. Bear with me one more minute. Here we go, chapter 10. Pull this up. Okay, those are up. Now come back to here, and I got to share with you guys. Share screen, and I'll share that screen. And voila. You see a screen now?
Yes, I do.
General rules of probability. Okay, so we'll pop it up there. Okay, so let's go find that equation.
Yeah.
That's the one that's kind of the one you're concerned about.
Well, that one, and then the one 2 slides from that one. Yeah, that slide. And that top one.
The top one.
To see how the probability of B given A is in that equation, but then we're supposed to use that as the numerator for the other equation. And I just keep getting confused.
Well, maybe I can clear it up with this. Here, I'm going to write on this slide. I think you can see it.
Mhm.
If A and B are independent, then let's get this off of that line. Then P of B given A equals P of B.
Right.
So the only difference between these two equations is this term right here, this P of B given A.
Okay.
And so all that says is that this rule always holds. This is true always. If they're independent, A and B,
Mm-hmm.
then you can reduce this one
To the bottom
to
one.
the bottom one. So you only need to know, quote only, need to know if the events A and B are independent
Okay.
to know which one to use. So then you ask yourself, are they independent? And the answer to that question, let's go to this. Well, that's not a very good question. No, that's not a good idea. Events A and B are independent if the occurrence of one of the events does not impact the occurrence of the other one.
Right. And usually if the question is asking us what is the probability of B given A, then usually they're already, based on the question, we have to make sure we figure that out. But usually it's that they are dependent, and that's why we're having to use that top one.
Right. So then restate your question, because I guess I'm not getting to it yet.
So I'm confused as to how I find the second part of that top equation. If that is actually, because that's how we're supposed to plug that in to the numerator. Yes, that highlighted part. We're supposed to plug that into the numerator of the other equation, but that's also what we're trying to find.
Right. That's impossible, of course.
Right.
No, you are absolutely right. So the problem has to give you two of these three terms.
Okay.
Find the third.
Okay, so it has to give us some sort of piece of information of what A and B are together.
Right. Right. You have to know two of these three terms. And if you get two of the three, you can get the third.
Got it. So then the problems that I was struggling with in relation to that, I was probably overthinking and the information was there. I just wasn't seeing it.
Let's hope it was there. It should
be. Yeah, okay.
It should be there. Right. Right. So yeah, you have to be, and in the same way here, you can, if you're given two of these three terms, you can find the third.
Okay, got it.
Right. And it's, yeah. I don't know that overthinking is a fair criticism. I mean, I just think about it a little bit and you'll be okay, I think.
Okay. And then my next question for chapter 10 was, I just typed it actually into the
chat
window. Yeah. Sorry, I think that's easier for me.
All right, well then I have to go find it. Let me get rid of this. Let's see. This thing there. Chat session. Where's the chat session?
For me, it's usually attached to the actual, or I can get to it by going to the video screen.
Right. My video screen is now reduced in size for some reason. We have a lot of people on board today. Stop sharing. Share. Oh, you know what? Let me try this. No, not that one. That's not what I need to try. Why? You see my screen? It's just this tiny bar now.
Yeah, I see it. It's only like a small window.
Right, I don't have to make that bigger. Wonder what happened. Stop share. Let me stop share and see what happens. Oh, there it's back. Okay, here's the chat session. The Centers for Disease Control, 23rd. So is this your question, Nicole?
Yeah, and particularly, how do you get the probability of at least one?
The probability of at least one is equal to, and I'm going to share this screen again and we can type it again, okay?
Okay.
Share that screen. Okay, so you see the chat?
Yeah.
I don't think we need to see the chat, but okay, so for this one, I'll just type something else here.
Okay.
Because I think it's easier to, sometimes it's easier to read than it is to listen. So, but the probability of at least one is equal to 1 minus the probability of none. Because at least one means that something must happen.
Right.
And so if you break up everything that can happen into two groups, then one group is that nothing happens, and or that no one succeeds, and the other group is that at least one person succeeded. Those two groups make up everything.
Right.
So let me say this. The probability of that equals 1. The probability of at least 1 plus the probability of none equals 1. Because anything that, I mean, we have so many people can succeed, and the number of people that can succeed or not have the infection is 0, 1, 2, 3, 4, 5, however many people are in the group.
Right.
So this is none. And then this is, well, at least one. Could be 1, or it could be 2, or it could be 3.
So you take the probability of the chance that none of the three of them have the infection and subtract that from 1, and that would give us our answer.
Right.
Okay.
How do you get the probability of none? That may be an issue too. I don't know. But the probability of none.
Because the probability of none of the three of them, I think what I was originally doing was I was just doing the probability of one of the people having it times the probability of not having it times the probability of not having it. But
right.
That's not quite right. So instead I would do the probability of not having it times not having it times not having it, all of that subtracted from 1.
Exactly. You got it.
Okay, got it. All right.
Perfect. Perfect.
Okay, thank you so much.
You're welcome, Nicole, anytime. Any more questions before we get to chapter 11? We interested in doing chapter 11 share like we did last time? Somebody say yes or no?
I would be.
Yes, please.
Okay, we'll go get chapter 11 slides. Da-da-da-da. Get rid of that. Don't save, obviously. Share, okay. So now I'll go open this again. Chapter 11. Well, I need to go back to the course again, darn it. That's the best way to do this. So here it is, chapter 11 slides, quiz, chapter 12 slides. Where's chapter 11 slides? Why aren't they in order? Oh, there they are. Okay. Okay, so now I gotta share this screen. Hypothesis testing is normal distribution. Sorry, I'm ahead of myself. Share screen, where is that? There we go. Share screen, there it is. Share that screen, start share. The normal distribution. Okay, so let's pop this up. The normal distribution is used extensively, and it is extremely important in statistics. So we have to start, so we start with that, and so let's learn what it is. Anyway, let's do that. So these are some sample slides, and this is a frequency slide, a frequency representation of the BMI, the body mass index of men above 55, I think. It says up here, 60 years old. And the mean is 29, and the standard deviation is 6. Now, does that, so are these terms okay, the mean and standard deviation? Yes?
Yeah.
Okay.
For me.
If somebody has to say no. If the answer is no, we can talk about it. So, and if I say the distribution is normal, what that means is that I can draw a continuous line like this one, and the mean will be right in the middle at the top, and the mean is 29. And the BMI, the standard deviation rather, is, in this case, is 6. I can mark this off in groups of 6. I can mark it off in groups of anything, but groups of 6 is very important thing to do. So 50% of the data is on each side of the mean. This is a symmetric curve. The right side is a mirror image of the left and vice versa. Okay, so that's a distribution. Now this curve evolved from, I don't know that I have a slide with that in here.
How do you get the 6?
It's going to be given to you.
Oh, it's always given?
Yes.
Okay, thank you.
That's always given. And the mean will be given generally too for what we're going to be doing. So, okay, so the other, now the next thing about this is that so I can use this notation N29.6 to represent this curve. So the only thing I need for the normal distribution is the mean, 29 in this case, and the standard deviation, 6. And that tells me everything I need to know about this curve. Turns out, I mean, it's just lucky that it does, but nature was nice to us. So this curve, by the way, goes infinitely out to the right without touching the horizontal axis, and it goes infinitely out to the left without touching the horizontal axis. Just keeps on going. And I use the symbols N, mu, where the mu is the standard deviation of the population, and sigma, the standard deviation of the population. I can just name my distribution like this, as in this chart. So here's a curve, this top one, this purplish one, blue, in 15.2. So the mean is at 15. So the mean of the population is 15, and the standard deviation of this population is 2. And the green one is in 15.4. So the 15s are in the same spot. But what happens, the 4 causes the distribution to get wider. Standard deviation measures the spread of data. And so the bigger the standard deviation, the more spread the data is. So that's more, the green is more spread than the blue, and the red, whose standard deviation is 6, is more spread than the 2 or 4. And here's the three curves where the standard deviations are all the same, 3, but the means have changed. So here the mean is 10, here the mean is 15, approximately, I guess, and here the mean is 20. So so you can draw the curves like this. You could draw the relative curves. However, what is amazing about the normal curve is that even though there's all these curves in 29.6 and anything else, I could get by with only one curve, the standard normal curve, they call it. Okay. I only need, oh shoot, sorry. How did that happen? Share screen, I guess. Yeah, okay. So what that means is that I'm going to take the 29.6 curve and I'm going to change it to the 0.1 curve. The 0.1 curve is the standard normal curve. It has mean 0 and standard deviation 1. Okay, so, and I can change the 29.6 curve into the 0.1 curve with this equation, z equals x minus mu over standard deviation. So take an example. The one that I have here is, suppose I take a BMI of 39. If I put 39 into this equation, I'll get 39 minus 29 over 6, which is 10 over 6, which is 1.67. So this 39 is directly equivalent to 1.67 on the 0.1 curve. And I think after we're done with the chapter, you'll understand why we do it. Right now, we just need to know that we do it. And the z is also called the z-score. That's what I generally call it. Most people call it a z-score. Where does 29 go? If I take a BMI of 29, I put a 29 in this equation for x. So the x is on this, is up in the top curve, and I am trying to put it down into the z, to the bottom curve, the z-score curve. And I'll put a 29 here, minus, the mean is 29, so I get 29 minus 29 over standard deviation, which was 6. To have 0 over 6, well, that goes to 0. I should have that on this chart too. And 23, if I get 23 minus 29 over 6, I'll get minus 6 over 6, which is 1. So the 23 goes to 1. So this standard deviation, which I had marked off on the previous chart, the 23 goes to minus 1. Anyway, this equation converts a number in the original population, in our case, the 29.6, into the standard normal curve, 0.1. Okay, now my wife is making a noise in there. Is that bothering you? Anybody?
No.
Okay. Okay, good. You know, are we doing okay here? Too slow?
So far, so good.
Okay. So here's another example. I took a distribution whose mean was 10,010, 1010 rather, and whose standard deviation is 20. I have that here. My standard deviation is 20, and I marked off my lines of 20. This one converts to 0, 1, 2, 3, just like that. So this is the curve we're going to be working with. We will be given a problem with this curve, with this data. We will, before we solve the problem, we have to standardize it, so we put it in here. And we'll see how that works. And here's a good, go to this website, and I think you'll find some neat stuff there. Insightful and delightful, maybe even, who knows. Okay, so we have to standardize these things. Well, why do we do this? Because you want to ask a question like, what percent of men over 60 have a BMI less than, well, let's skip to the important question here. Here's our BMI for the population of all men over 660. Suppose you have a person come in and have a test of BMI equals 46. Well, 46 is clear out here. How bad is that? So I need to know what's the probability of him, which part of the population is he in to have a 46? Is this way out there? Well, from the picture it is, but sometimes from the picture you can't tell. So what you need to be able to do, so what we start with, we ask some typical question. What percent of men over 60 have a BMI less than 39? That's what we need to find out. So let me go back to this chart here. Not that one, this one. So what percent of men have a BMI over 39? Well, if I draw this picture, have this picture drawn, the BMIs over 39 are from here out, and that equals the area under this curve. So kind of this area here. You know what, if I get out of here, I can do this. Range, I get this. I think I can use this. I don't know which one of these I can use. This one, I guess. It equals this area here. Oops, that didn't help. Well, the color's bad. Oh, the color's not good. So it's this whole area here, from 39 out. That's under the curve. This is the percent of men who have a BMI over 39. The percent of men who have a BMI less than 39 is all the rest of it. And I can now begin to ask all these other questions. What percent of men have a BMI less than 23? And do all that. So the percent of men, the BMI less than 23 is this whole area. So the question is now, can I find these areas? Well, it turns out you can using some tables, and we'll see how to do that right away. And the first thing you'll do is change it to the 23 to -1, but we're getting ahead of ourselves. Okay, so that's why we do it. And here's the answer of how to do it. I use my z-score formula, and I compute the z-score that's equal to x minus the population mean over the population's standard deviation. I put in x equals 39, mu equals 29, standard deviation is 6. I make that computation and I get 1.67. And the probability that the BMI is less than 39 is equal to the probability that Z is less than 1.67. So any question that you can ask about the BMI can be translated into a question about Z, where Z is from the standard normal curve. And here's how we read the standard normal curve. You've got a table in your book And I don't remember the table number. So let me look it up.
It's table B, Professor.
Table B?
Yeah, B as in boy.
B as in boy. Okay, so it's table B. I think it's on the back cover of the book even. Well, that might be the
That's a different one, actually. It's a couple pages in from the back of the book.
Okay, so it's a couple pages in. So to read this table, this is the z-score column, and there's a negative z-score column also. So it would help if you would look at that table, pull that up now. And to get 1.67, when you come down here for the z-score, you find 1.6, and you go over here to this heading, which gives me the second decimal. So this 7 gives me, if I come down here and take the intersection, I get 1.67. Excuse me. And this table tells me that 0.95 or 95%, 95% of the population, 95% less than 39, will be less than 39. So this whole area here represents 95% of the population. You with me? We okay?
Yep, so far.
Okay, good. All right, well, that's how to read the table. Question is, how do I get the amount greater than 39 now? Well, the answer is the total area is 1. Actually, I think I have a slide about this. We have numerous slides. So the BMI less than 39 is Z less than 1.67 is 95%. The BMI greater than 39 is 1 minus BMI less than 39, because the two of them make up the whole curve. So they sum to 1. The less than 39 and the greater than 39 sum to 1. And so less than 39 is 1 minus, that should, okay, wait, greater than 39 is 1 minus less than 39, which is 1 minus 0.95. And so that means about 5% of the data of the BMIs are greater than 39. What about between 22 and 39? Well, that's a little harder, but let me go back to this other slide, to the picture slide, and I'll get rid of this. The way to do this one is I first get the area to the left of 39. Okay, so to the left of 39 means from this bar all the way left. So that's the BMI less than 39. And then I need to get less than 22. See, that's 11, 17, 20. Oh, 22 is, that's not 22, is it? 36, 7. Oh, that is 22. Okay. So if I take everything less than 39 and subtract from that everything less than 22, I get everything between 22 and 39. Okay? So, that won't work. So to get, so I look up the BMI less than 22, and I use that, and so I can use my table, this table back here. Come on, go back. I can look up less than 22 using this table. Now, remember the innards of this table, the body of the table, gives me the area to the left of the z-score. All right. So There it is. So I look up 22. I take,
Professor, I have a question.
sure, go.
Oh, so as you were saying about the area to the left, that's always going to be less than in the question, right?
Yes, that's the less than.
So then if it's a greater than question, we're always going to do the 1 minus probability.
Yes.
Okay, just checking. Thank you.
No, it's great question. So the first thing you have to do with a 22 is put it into the z-score. I should have done that here, but you put it into the z-score and you'll get minus 1.17. And then you look up minus 1.17 in the table, and it should be 12% area, approximately. And and we already have the 39 is 95%. I'm rounding here, right? And so the area between is the larger area, 95, minus the smaller area, 12, leaving me about 83%. So you're beginning to see what you can do with so if you were to find a person with a BMI greater than 39, he would be there's about a 4 or 5% chance that, because there's greater than 4 or 5% chance that you would find such a person. So he's in it. So that's a rare person, which in this case is indicating that the BMI is very much higher than normal. And if your BMI curve has been established, that this is a good normal, not only is it the average normal, the average of what people have, but this is an acceptable number. If this is an acceptable number for over 60, and you're clear out here at 39, which is 4%, you are well above average. You have way too much. And that's the purpose of a curve like this, that you can start to begin to measure how bad or how good your actual X value is. And in this case, a high X is bad. A low X might be bad too. I don't know. But probably not. I mean, it's probably not good. Okay, so that's why you do it with the normal one, and the normal one works. Many things are normal. In fact, in chapter 12 or 13, we begin to see the great importance of that. Okay, so here's kind of a rule, and this is a nice little rule. 68% of the data, you have a population. And I'm going to reduce it to the standard normal curve, but it doesn't have to be. We'll go back and talk about that. But 68% of the data, approximately, is between one standard deviation below the mean. Here's one standard deviation below the mean and one standard deviation above the mean. So 68% of the data is between these two values. 95% of the data is between plus or minus 2 standard deviations. And 99.7% of the data is between plus and minus 3 standard deviations. So the important thing here is that if you have a population, let's go back to the BMI one. If I have a population 29, and we already know that this 23, the standard deviation was 6. So the first standard deviation is here and the second one is here. So 95% of all men over 660, 95% will have a BMI between 17 and 41. Just in general, I mean, that's a statement. I'm pretty sure this data came from something that's been evaluated maybe a few years ago, but I'm pretty sure these means are actual numbers. that I didn't just make up. So you can say that 95% of the population has a BMI between these two values. 68% have a mean between here and here, 23 and 35. So I've worked with some really, really smart people in the past, and I mean, ridiculously smart. And a lot of people have called them the Sigma people, because here's 1 sigma, here's 2 sigma, 3 sigmas right there. The 6 sigma is way out here. So these guys are really extremely smart. Now, this is not you'd have to use the IQ curve here, but that's why I call them. So you could kind of remember, that's how I kind of started to remember this. These are the 6 sigma guys. These guys are so far off the chart that it's ridiculous. They were scary smart. But 95% of the population will be here and here. So for example, the average population, the average IQ of a U.S. adult is 100. And I believe the standard deviation is 16. It might be 12, but 16 we'll say. So if I say 16, then 2 standard deviations is 32. And 2 standard deviations less than 100 is 68. So 95% of the population will have an IQ between 68 and 132. 95% is between these two values. So if you have a friend with an IQ of above 132, well, they are in this area here, which is only 2.5% of the data of the population. So they're in the smarter group of people.
Professor?
Yeah.
I had a question about that actually, and I think you might have just answered it. So it is 95% or 68%, those numbers are within the standard deviations, right? So for example, on this slide, when I paused it and did the calculations for your examples on the left, the second to the last question, I didn't get 5%. I got 2.5.
Well, I may have made a mistake. That would be this question down here on the right?
Yeah.
So the BMI
that correlates to the probability of BMI is less than 17, because less than 17 would fall within that 95 range, but it's only on the left. So it's 5% split on both sides, right?
Yeah, and you're absolutely right. That's
okay.
0.25.
Okay.
You're absolutely right.
I wasn't sure about that. Okay.
I don't have a slide number with this, but I'll fix the 97 slide, the 68, 95 slide. Okay, I'll fix that one. Okay, so we'll fix that. But okay, I'm just verifying these numbers here. But you can do kind of other things here. Oh yeah, that's what this is. So just using this data, I can get what's the probability of the BMI is between 17 and 41. Well, 17 is here. 3 standard deviations. Wait a minute, I've got almost only 2 standard deviations. Oh yes, 17 is 2 standard deviations. Sorry. 20, oh yeah, okay. So it's two standard deviations. And so I've got, okay, 17 to 35. Let's say that. So that would be from -2 to 1. 17 is -2, 35 is 1. So that would be from here to here. Well, you can break up this chart into various little pieces. if you draw the line right down the middle, then you get 34% between the middle line and that line. That's half of 68. And then you're going to take and go half between here and here. I think that's 13.5% to go between here and here. Let me get out of here and I can write this for you. So that'll be 13.5 in this area. And I'll get 34 in the 34 here in this area. And I'll put this other line in here just for now. So now I can go back. So I've got 34% between these two. I got 34% between these two. And I want to go from where do you want to go from? This 17 to 41? We'll go from 17 to 41. So here's 17 is minus 2 to 41, which is plus 2. Well, that's 95%. So we already, so that one's easy. If I want to go from 29 to 41, well, 29 is 0 to 41 is 2. So I want to go from here to here. Well, I would add these up, 34 and 13.5. So it's this area plus this area. That'd be 47.5, which is what I have. And then this area here is, what is this, 2.5% or something like that? Let's see, 47.5. Yeah, this is about 2.5%. This is a little less than 2.5%. So if I added, see, so if I want BMI between 29 and 31, I want this number plus this one plus this number, which I think is like 2.5. I don't think it's not quite 2.5. How can we get what that is? Well, it's half of 99.7. Where's my calculator? 99.7. 0.7 divided by 2. That's 49.85. So this area is minus 13.5 minus 34 is 2.35. So this area right here is 2.35. $2.35. Okay, so now we can get this area. So if we look for between 29 and 41, that's this area plus this area plus this area. That's which is 815, I hope. Is it? 29 to 41. Oh no, 475. My bad. I'm sorry. It's just 34 and 14.5 is. Okay, I'm getting myself ahead of myself. Okay, 29 and 41. 29 is 0, 41 is 2. So that's these two, and that's 47.5. We got that. For this one, it's 17 to 35. 17 is minus 2 to 35 is 1. So that's from here to here. Well, that's 34.5 on this side and 13.5 here. So it's 13.5 here, 34 here, and 34 here. So that's 68 plus 13.5. And that's 81.5. And I do have an error with this one. I was informed about. That should be 025. Did I mess that slide up enough? You done with this? Are we okay? Anybody?
I'm good.
I'm good.
Okay. So there's the 6895 rule stated in terms of Z. Okay. And now here's just another example. Get rid of this thing for a while. Women's height follow the N64.5, 2.5 normal distribution. And they asked the question, what percent of women are shorter than 67 inches, which is 5'6"? Well, I draw, so this is a curve with a mean 64.5 and standard deviation 2.5. So I draw my curve and I put the mean at 64.5. It's impossible to draw what the standard deviation looks like. So you just draw a curve and you have to remember that it's 2.5 inches. So I wanted to find out what's the percent of people less than 67 inches. 67 here, and I want all of this area then. I want all this yellow area. And the way to work that is you first compute a z-score. Oops. You first compute a z-score. Z equals x minus mu over the standard deviation. And the x is the value that we are looking for, or that the question is being asked about. So we're asking about 67 inches. And so I put my x in here, the mean is that, and the standard deviation is that. I make the calculations, and in this case, I get 1. So this 67 is equivalent to 1. I go look up in my table and find that what happened? That I can use the 6895 rule, that it's less than the probability of being less than 1 is about 84%. You can just add those numbers up from the table. How do I get that? Well, you get that from here. To the left of this guy, the left of the mean is 50%, and from the mean to 1 standard deviation is 34%. So 50 plus 34 is 84. Okay, so that's how you can work those problems. Oops, still gonna do this again.
Professor?
Yep.
I think that some people we don't have too much time left, and I think some people are saying that they'd like to go over some of the chapter 12 material.
Oh, okay.
I don't know if everybody's feeling good with the chapter 11 stuff and we can move on, or
It's fine.
I don't want to cut anyone off if they still have questions about chapter 11.
Does anybody have questions about chapter 11?
I have a question.
Okay.
For the exam, are we allowed to use our book for the table?
Yes.
Okay,
That's a definite yes.
thank you.
You have to have the table in front of you.
Professor, do you think we can maybe use the book as well to help us with the exam? I, for one, would need a little bit of help. I can't retain all this information. And even if I make my own notes, I still feel like I need a little bit of more help. Sorry.
You don't sound like mine.
Yeah. I have a new puppy, so it's a little crazy.
Mine aren't puppies, but they have that same word. Well, I'll tell you, the issue with using a book is that you need to be able to still be able to finish this in time. And if you're
Right.
using the book, you don't want to have to rely on it a lot because it'll slow you down and you won't finish. So you really have to have your notes and stuff pretty well in hand.
Right.
When is the exam due?
I'm not sure. I think on the 29th.
This Tuesday, yeah.
Yeah.
Tuesday, okay. Can you get by with a page of notes?
Yikes. I can.
Let's get by with a page of notes. Okay.
All right.
We'll have a page of notes, 8.5 by 11.
You said double-sided for the exam one. Is that still the case?
Double-sided, of course.
Yeah. Okay.
And then you'll need the table too, the normal table.
Okay. Thank you.
I don't think we get to the other table yet, right? Right. No, I know we don't. Right. Okay. More on chapter 11. No, we want to go to chapter 12. Do I need slides or do you have some specific questions? Don't everybody speak at once? Oh, I keep doing that. Let's not do it like that. Let's go back to this and get chapter 12 slides. I think we probably only have time for one of the distributions in chapter 12 is my guess.
For the people who wanted chapter 12, is there anything in particular so that we can try and touch base on both aspects? Is there anything in particular that people had questions on within like the first section and the second section so that we could try to touch base on both?
Nobody's answering. So we have two distributions we have to talk about, the binomial and the Poisson.
Since no one else is, I just feel bad I'm like the only one talking, but if no one else is going to answer, can I direct you to, let's see, what was it? Within the part one, so the binomial, hold on, let me grab, 1, 2, 3, 4, 5, 6, 7, 8, slide number 9.
Would this be slide 9?
No, keep going. Keep going. 2 more. The next one. This one. Where did the factorial stuff come into play? Is it because of the word exactly? Is that where it came into play? And how did that get incorporated into the equation? Because on the previous slides, the equation
those are the same things. Let's go find this NCK. If you were to write this out, it's n factorial.
Oh, okay.
Those factorials that are written on that slide are exactly this.
Oh, got it. Just written out. Oh, okay.
Right.
Which you're telling us from the videos, you were telling us we can just use the calculator for that.
Just use the calculator to do it, yes.
Okay, so that slide that had the colorblind aspect, that was just basically you explaining all of the steps that wouldn't happen, right?
In fact, factorial, which is 25 factorial. I think there's 25 people here, yeah. And then n minus k. And I mean, so what's k? K is 5. That's an x. It should have been 5. Yeah, n minus k, which is 20 factorial and 5 factorial. And that's, I mean, if you work all of this out, it becomes this.
Okay.
Right, if you work that out. Okay.
Oh, because yeah, you cross out the denominators. Okay, I get it. I just saw that, all of that extra type, and I got a little overwhelmed.
Right, understand, yeah, okay.
Then the only other thing, I would love it if you could go over that binomial mean and variance aspect again. Sorry, if you go back to the blind the colorblind, it was the slide after that.
This one? No.
No, the slide after that one.
Well, actually, the one thing about this book that I don't like is that this equation right here that I'm putting my mouse on, that is an extremely important equation, because let's say that let's say that you win 20% of your games. Let's say you play a certain game, darts, and you win 20% of the time. So if you play the game 100 times, how many games do you think on average you will win? You're playing the game 100 times and you
20.
win 20% of the games.
20 of them.
You will win 100 times 20%, 0.2. That's 20, which is 20. So on average, you're going to win 20 games. That's what you can, on average, win. That's how many you would win. Sometimes you might win 50, sometimes you might win 3, but on average, you would win 20, if your 20% is right. Well, that's what this is. This is the expected number of games that you would win if you played the game n times and your probability of winning each time was p. On average, this is how many you would win. Okay. And the standard deviation of that would be this equation, a little less intuitive, but it's there. And anyhow, you can prove this mathematically, but we won't. And so this is the standard deviation. So the mean is n times p, and the standard deviation is this. And it's that simple. I mean, there's nothing, the math behind this is complicated, but we don't care about that right now.
So we would just be, like the example that's on the bottom of that slide, we would just be plugging in the values that are given, and that would be as complex as it would get. Okay.
Yeah, well, right. But it should get more than that. You should be able, we should be using this more, but unfortunately we're not. We should be able to say things like, I mean, you can take this equation and expand on it just a little bit and say, if I've got a 30% chance of winning, okay, I have an investment and there's a 30% chance that I'm going to earn $100 on it, then the expected earnings would be $30. 30% chance that I'm going to win $100. Well, my expected earnings should be $30. That's this equation, a little, right. And that's the importance of this. I mean, it goes way, way beyond n times p.
Okay.
That's what we've got with it for now.
Okay.
Okay. Now, you have some more questions about, I mean, you want me to go over this binomial stuff? Anybody? I mean, if you do, I will. If you don't, I won't. If nobody needs it, I don't need to do it. If you want me to, I will, even though it's running out of time. Nobody needs it. I like that, if that's true. Or nobody's speaking up, maybe. We're okay? Any questions of any kind? This is not a picture of me.
Yes, Professor, this is Janina speaking.
Uh-huh.
And I was just wondering, is there a hard and fast rule or some hints you can give in when we're using the binomial as opposed to the Poisson?
Yes, there is. The binomial and the Poisson asks you for a specific number of events happening or not happening. I mean, they ask you, what's the probability that 6 people will do such and such? The big difference is that the Poisson is the situation is a rate. Everything is a rate of some sort. So you've got 6 people arriving at a bank. What's the probability that 3 will arrive in the next hour? You've got 12 cars are passing through a tunnel every 12 minutes. What's the probability that 9 cars are going to pass through the tunnel? What's the probability 39 cars are going to pass through the tunnel? So Poisson is a rate, and the number of, so if you read the problem in a binomial, you have a fixed number of experiments. You're going to flip a coin 20 times or 19 times or something. So you have a B, N, P. You've got a fixed N. In a Poisson, you don't have a fixed N. You have just the probability of so many people arriving in an hour, in a time, because that's a rate. You have so many people that will arrive at a rate. You have hospital visits. There's a lot of other examples that I don't want to confuse it with. I mean, in terms of geometry, but Poisson is basically a rate, whereas the binomial is just a fixed event. Fixed number of events are experimented with. There's a fixed number of experiments. Poisson, I can have thousands of people arriving at the bank. I don't know, did that help any? I don't know if it does. Just, that's what you have to think about is Poisson has a rate, and if it mentions rate, then you use the Poisson for sure.
Okay, that helps. Thank you.
That should help a little bit anyway. I don't know if that's a definitive answer, but might help some. Others? So how are you doing with the course, everybody? Oh, is it going okay? I mean, that's a yes or no. You can say yes or no. I don't know who's answering.
Not for me, it isn't.
It isn't.
No. I find it very, very difficult and confusing, and I feel like there's no structure. Maybe because I haven't been taken a math class in a really long time, but it's very discouraging, and I feel like I'm going to do poorly in the class, and it's just going to ruin all my grades that I worked so hard on. So.
Well.
And I feel like no matter how much I'm listening to you and even going through the notes, it's not clicking. Like, it really isn't. It's very difficult for me.
Okay, that's acceptable. I think for anybody taking an online math course is just really hard. I mean, it's just really, really hard. But what you and I need to do is sit down and talk for 15 minutes, one-to-one on this Zoom, say, and I think maybe we can make some progress with learning how to learn the math.
I guess. I feel like though we just have a few more weeks to go, and I'm so honestly just completely lost in it right now. That's how I feel today, that I don't even think 15 minutes with you is going to work at all. I just feel like I'm struggling, and whatever scores I'm getting on the quizzes, it's with a great deal of stress on my part. It's very disheartening. But again, it could be just me. But I have to be honest that every time I have to sit down and start going through the material, I feel like I get such anxiety. I don't know. Maybe that's normal, but.
Well, it's not an unusual thing. I mean, I think that happens to more than one person,
Yeah.
to more than you. But
I mean, I think what I'm going to do is I'm just going to do the best I can, and I'm just going to hope for the best. But it's
Well,
and I almost can't believe, and this is the truth, that the university is actually charging so much money for a class like this, that and expect some kind of expect it to be a positive thing, because I don't think it is. I just think it's very. I can't believe that they're actually doing it this way. That this class is being offered this way.
as an online course?
No, I mean, this is an online class. I mean, this has been all these courses that we've been taking have been online. So I understand that part, but I just don't understand how. I don't know how else it can be taught where the material could actually be learned versus just kind of trying to whiz by with memorizing parts of it so I can just do well on the quizzes and do well on the exam. I mean, I would think that the main goal would be to actually try to teach a class and want the students to kind of understand the material versus just trying to kind of pass an exam. You know what I'm saying? Does that make any sense?
No, I do know what you're saying, and that is there's a fair number of people that don't think you can teach a math course online.
Yeah, well, maybe then they should reconsider how they teach these classes, and maybe next time they should have one class where the students would actually have to go into the school or something like that, because I think I just think it's very disappointing. As somebody who's trying to sort of complete classes and paying over $1,000 for a class that I'm doing so poorly in, but I'm studying. So it's very disheartening. That's my only thing that I can possibly say.
Well, I'm glad you are expressing that.
I admire the people who are doing well. I can tell who's doing well because it seems like they have more of a grasp on it. And even when they ask questions, like they definitely get it more than I do. And it's upsetting to me that I can't even, ask a question because I don't even know what I'm asking. I'm, like I said, I'm just doing the best I can with looking at the notes and trying to figure it out on my own. And I'm only hoping for the best, so.
Why don't, so, let's see. So, let's see, pardon? Oh, sorry.
I'm sorry, this is my daughter.
That's fine, that's fine.
Make her stop.
So, the chairman of your department wrote a letter to the chairman of my department, and the chairman of my department sent it to somebody else who's talked to me about the exact same thing that you're mentioning. And
Right.
he talked to me this morning, actually, about this. And I now understand. I never saw either letter. I just had the conversation, even though I'm the one doing the teaching. And I now understand the problem a little better, from what you're saying. So what's the solution, though? That's the question. Let me say this, too. My face-to-face students have the same problem, exact same issues. I teach a calculus course for business majors, and they have the exact same issues. They don't understand it. They ask the most basic questions, and they don't remember it, and they don't grasp the concept. They are only looking to, where do I put the 6 now? Where do I put the 7? Where do I put the division line? They're not grasping the concept. And it's the hardest thing in the world to teach the concept. You have to spend time with a person to teach a concept, to teach them how to learn the concept. as opposed to fighting every word. You can learn to grasp the big picture. It's not easy, and it's not easy to teach. But I think I can help. I think. I'm not sure. So if you want to sit down sometime on 15 minutes, anytime, we'll set up something and I'll see what I can do with you.
Okay, maybe after Thanksgiving, I can shoot you an email and we can talk on setting something up. I mean, I would love it if I can maybe have some help with the next exam at least, and you know, with the next few chapters that we're working on. And
exactly. So can I ask who I'm talking to, because I don't know?
Oh, I'm sorry. My name is Georgia.
Georgia. Okay.
Yep.
Georgia, this is Nicole. I am dealing with the same thing that you are too. I feel like I am getting the material sort of, but honestly, the thing I am doing is I keep taking the quizzes until I can get a quiz where I'm lucky enough to have all the questions on the quiz that I actually know how to do. And then that's the only way that I feel like I'm doing well in the course. But I am struggling with the fact that I am the type of person that I actually want to know and understand all the material. And when I don't, I get frustrated. So my frustration is coming from the fact that I am fully learning and doing well only to do well in the quizzes so that then I can do well in the exams. But I don't necessarily feel like I would be able to feel comfortable explaining all of the material to another person or teaching it or whatnot. But I understand your aspect in that, and it takes a lot. I've been feeling like I've been teaching myself a lot too, and it is really difficult, especially with a math class, to try to do this online.
It's really hard. I mean, the last exam that I took, which was chapter 9, I took it so many times, and I finally got a 10, and I was like, well, all right, that's great. And I kept on taking it, and it just kept on going. It was going lower and lower, where I was like getting 5s. I was like, how could this be possible? I just got a 10, and it just was it was just becoming worse and worse. And I think what I was doing was I just got myself so upset over it because I felt like I can't get it. And then I lost my my mojo completely, and everything just started looking the same. And I couldn't even figure any of it out.
Yeah, I have to definitely take the quizzes over a course of a couple days,
Right.
where I see that I do better. Are you by chance taking screenshots of the quizzes as well, like of the quiz questions?
No, I'm not. I should, right?
So, yeah, that's actually one of the ways that I have been teaching myself is as I'm taking the quiz, I will take a screenshot of each individual question, and I save it into a folder. And then that way I go back and I look at which ones I was getting wrong, and I can see what answer I got and then what the correct answer is. And I know the answer. Does that make sense? I know what I did wrong, or I'm able to figure out it for the next quiz or whatever.
So you pretty much keep on taking it, and you've pretty much taken all the quizzes and you know all the answers, kind of, sort of, right?
I mean, as the professor told us at the beginning, like that's kind of our advantage for this class. And I hate that I'm doing it again, that I'm doing it to get a good grade, but that is what I'm doing. But
Can
it's
I
the only way.
Oh, excuse me.
Huh?
Well, let me interject here. There's an old saying, the way to learn math is to do math. And so even though you think you're not grasping the concept, if you're able to do the problems without just memorizing the position of the answer or what the answer to this question is, if you're able to actually work the problems, you are learning math. And you're not expected to be able to go out and teach it tomorrow.
Okay.
But at least you are learning. You have learned it. So in the future, if you ever come across it again, it should come back easier. I mean, don't be too hard on yourselves if you are succeeding in doing what you're doing. Is this Nicole?
Yeah.
Okay. Yeah. So don't be hard on yourself yet. I mean, that's not right. I don't think.
Okay. Well, then Georgia, that's the way it's been working pretty well for me. I don't necessarily get them all correct, but it's been the way I've been going back and teaching myself the material and keeping track of all the questions and stuff like that. And it's been helping me.
Okay, thank you.
Now,
Yeah.
Georgia,
Yes.
you need to reach out. You need to reach out to me once you start taking these screenshots and you don't know how to work a problem, put it out on the forum. Ask, how do I do this? Somebody's going to help you, and I can help you. I mean, now, that's you have to reach out. I had no idea that this was the problem, and and here we are 5 or 6 weeks in. I don't know.
I mean, it actually just got, it just was getting worse for me. And
Right.
it started out kind of, okay, all right, this is not terrible. I can do this. And then it just, I don't know, there came a point where I just went, oh, like, I don't know.
Okay. Well, well, we caught it. We should have. It would have been nice to have caught it earlier, but we didn't. So that's okay. We are here, and so if you want to talk to me between now and the exam, spend 15 minutes. By after Thanksgiving, do you mean maybe Friday?
Yes, maybe Friday.
You email me
Okay.
something, and I'll or we can set it up now if you want.
I guess we can. Yeah, I mean, it's up to you. Or maybe we can set it up for Saturday, because
I
Friday.
don't care.
I mean, Friday.
I'm open.
Okay. I mean, if you're okay with that, sure. Maybe Saturday in the morning, if whatever works for you.
You tell me what's convenient. I'm pretty flexible.
Maybe 9 a.m.
9 a.m.
Yeah, on a Saturday.
on Saturday, November 26th.
Okay.
Make sure that's Saturday.
Yeah. And then should I just dial into your office hours?
Yeah, I'll just sign on just as normal. And Nicole, you're welcome to join us.
Okay, thank you.
I mean, I think Georgia won't mind. And
Oh no, I don't mind.
and so, but it's going to be a conversation between Georgia. I mean, not Georgia. Yeah, Georgia. And Nicole, anytime you jump in, it's always a good time. So, anytime you want to jump in, later on. All right.
This is also
Wait, I can barely hear you. There's some other noises happening. Okay.
Sorry, I just kind of jumped in. This is Melissa, and I wanted to know if I could actually join into that meeting.
Georgia, do you care?
No, I think that's fine.
Melissa joins us?
Yeah, that's fine.
Okay. I don't care who comes.
Okay.
Okay, so I'll be there too. Thank you.
Okay, so, now the goal is to learn how to learn. I mean, to see if I can't help with that. But if we have to do problems in the process, that's fine.
Okay.
Okay, thank you.
You're more than welcome. Because that's the problem with an online math course, is that all I can do online is have these conversations like this and send you some problems. I mean, you've got a book, you could read the book. You don't need me to read the book. What do you need me for? To explain things? Well, that's what we're trying to do. I mean, it's hard to do online. Okay, let's be done with that then. Okay. So we'll just plan a meeting Saturday at 9 a.m. Is that okay?
That's
Yeah.
perfect.
Yes, thank you.
Okay, let's be done tonight. Is that all right?
Yeah, happy Thanksgiving.
Yes, good night.
Okay, happy Thanksgiving to you too, everybody.
Have a happy Thanksgiving.
Thank you. Bye-bye.